Hello. Today we'll discuss asynchronous read models. So from the sync read models, we'll go into slightly different world where our events will be performed by some kind of background jobs or in the background actually. And we'll also talk about the events ordering and what problems you could have, eventual consistency and idempotency. Hi, Tomek.
Hi, Łukasz. A lot of topics, but let's jump into the code now.
Hop, hop, hop. Yes.
Hop, hop, hop. Okay, so you can see here that we had our task view model builder, and before, in the last episode when we were talking about sync builders, we had something like that, right? And that was it. We were calling like some kind of call method here.
Yeah, exactly. So it was built just after the event was published, and then the sync read model was it was dispatched. I mean, it was dispatched. It was actually triggered, right? So the events were built just after the publish. When we think about the requests, so if you made a write request to modify some resource, then you were both changing the write model but also the read model, right? So this is the situation that we were in the previous episode. In this episode, we're taking it step forward.
Yep. So here we just added like active job base. We are having it here, and then we prepend raise event store async handler, and we of course changed the name to perform.
And just one more comment regarding the active job base. It may differ in your implementation depending on how you set up your Rails event store. In the default implementation in Rails, you can use active job base and it will work. And prepend, what it does, it gives you this event in form of an event. So you don't have to pass primitives here. Prepend will take care of this, and actually you can just work on the event object instead of doing it on your own. But obviously you can do it, implement it differently.
Yeah, and we could say that that's it, maybe, because it's like this is the change needed here, and from the subscribe, let's say, point of view here, we have the same. It's the same, right? Nothing changed here because we subscribe to the same events, so nothing changed here.
And the reason it works is the Rails event store internals, which we'll not cover right now, but you can take a look at the code. It's open source if you want and see why this happens. I'll just give you a small hint. Look at the composed dispatcher.
Yep. And yeah, I said that we could say that's it, but if you take a look here lower where we handle those events, we have something like task name changed at nil or task name changed at, and we compare it to the timestamp from the event, right? Metadata.
Mm-hmm.
And we've done that for all those methods that change the state of the read model.
Yes.
Right. And now we are going to explain why we do it, right?
Yeah. So let's jump to the Miro board.
Yeah. So basically we do it because of the order, right? Because like we have how we publish the event. So we like create the task, and then we change name to the importante, and and then we change the name to adjust translation. And in the ideal world, we also could process those events this way, right? So the task created the name changed to importante, and then adjust translation.
And this will happen from time to time, right? I mean, it's not uncommon, it's not unusual that everything will work well, but sometimes it may not work well. The events may go out of order.
Yeah, they might, and we could, for example, have just this order could be changed, like the task name. So we would have the second, the first, right? The first name would be the final one, let's say in this case.
Mm-hmm.
Or it could be even worse, right? Because we can have like this HMM. I would replace that with
WTF
and
exactly. Question mark, which wouldn't fit, by the way, but yes.
Exactly. But they can they can be processed in this way, right? Because
Yes.
why? Because like
Welcome to the async world, right? It's
exactly.
basically we gain this amazing benefits such as retrying, and we gain such benefits as we can just make our request a little bit lighter because we will not update the read model in the write request. But on the other hand, we are getting into this async world where, well, the order, but not only the order, but order is not guaranteed.
Exactly, because in the sync solution, as we discussed, it's like one after another, right? So we have an event, we update the read model, we have an event, another event, we update the read model, another event, we update the read model.
Yeah.
And even in async, but with one consumer, we also could have like the order would be also fine, right? Because one consumer will take one after another, one event after another, process it and update the read model. It would use some kind of queue, I assume, right?
Mm.
I mean, because the events, they are ordered themselves, right? But then we have like async and some kind of jobs that can, a few consumers that basically can pick up the event and do the job, right? And now we have like first consumer that took the task created, that's fine, right? But then the second one took the this one and the third one like quicker picked the third one but finished like here finished processing before the second one, and the order was not saved, right? The second one again we have the task with the important name.
Yes, but that's only one of the I mean, in the code, you saw the implementation with checking the timestamps for each the property of the read model. That's only one solution that you can use to solve this issue. There are more, and I think in one of the next episodes we'll show you how you can use a technique called checkpoints to actually save the checkpoint and then to use this information to actually deal with this ordering issue. But that's for later.
Yep. Okay, so I think we explained, right, why it can happen, right? So, for example, we have some kind of consumers that can pick up the events and do it.
Mm-hmm. Yes,
do the job in different order, right?
Yes. And this is something that can occur and will most likely occur in your system. Once you get some more traffic, it may not be visible when there is just one or two users working at two completely different resources. So if you decide to enter the async world, be prepared. And also, good news is that it is testable because you can, for example, if you're using Sidekick with Rails Event Store, you can set it up in the way that you can just modify different sequence of the events and see how your read model builder and eventually how your read model will look like, how everything behaves. So that's a good news.
Yep. So what's now, Łukasz? Do we want to jump into eventual consistency? Maybe?
Yes, let's do it. So another thing you have to watch out for is the eventual consistency. And this is both. This can be confusing for the user, but also it can be confusing and sometimes hard to sell it for the business. But let's start with the user. So as you can see in this Miro board, let me take some pen so I can draw. So as you can see that if we first create task and then it's applied to the read model and then we change the name of the task, then when the user starts reading the task in here, they will get this representation of the task, this read model of the task, which already has those two read models applied. But perhaps this event was not processed, right? So, but it happened. So the task should be named to this. It may be even the same user that actually changed the name. So they may be surprised that this name is not applied. And of course, there are techniques to deal with that. There is some technique called optimistic UI that you can use. So you can basically just return the name to the user, but the problem still would be when they refresh, they may see the old name because the new name was not yet processed, because there may be some latency on the queue, there may be some increased traffic, and the jobs may be busy and then they didn't process all the new events, right? So this may be a little bit of confusing. One of the other techniques, and the one that I really like when you use Rails together with Hotwire, is that from the event handler, you could stream directly to the user the new task name if it changes. Maybe with some update notification, because that would be slightly weird that when you just stream the name change and it changes out of nowhere, right? I may be surprised, maybe even a little bit scared. So that's one of the things that you have to take care of, that things may happen eventually, not initially. So in the sync read models, we called it strong consistency. Here it's called eventual consistency. And when it comes to consistency, from my experience, is also it may be hard to sell it to the business, because if you tell them that, hey, things are going to be eventually consistent, and they may be like, yeah, but what does it mean? You mean that the changes are not going to be visible like right away, instantly? They may say no. And that's a bad way of selling the eventual consistency.
But
yes?
they usually would say that because they are thinking about, I don't know, hours maybe, right?
Hours, yes, days, years, or whatever. But how I like to approach the things is to ask, would it change anything if this information would be available in a little bit later? And then you need to dig down what the a little bit later means. But if you usually want to talk about the seconds, and usually business will say it doesn't matter, right? Especially if this is some kind of report that you're building that is only displayed and analyzed maybe once a week, it is not really going to matter. Still, if it's only once a week, maybe you should use materialized view. All right. So
maybe users don't do the like rage clicking. Maybe not all of them, right? So they have to have like result half a second after they did some right?
Yeah, exactly. And also, as I mentioned, with just this single user, you can also stream this change, right, to the user when it's done. And so it's kind of I really like this technique. It doesn't require so much changes in the current UI. You can just use the latest framework possibilities and stream some changes. So that's pretty cool.
That's why Hotwire works such great with event-driven architecture, right?
Oh yeah, definitely. Yes,
great title for episode, right?
Which we didn't use, but it's a great composition. Keep that in mind. Maybe we'll go further in that one day. All right, but that's eventual consistency. There's one more thing that you should watch out for. At least one more thing that we'll talk about in this episode, and this is the idempotency. So basically, idempotency says that if your read model builder or your read model, if we use the mental shortcut, is idempotent, it means that applying the same event multiple times shouldn't change the result. And as you can see here, if you, let's say, create a task and then change the task name to task importante, and then you use this, then you change the name to adjust translation, and this event is handled multiple times. And why does it happen? It happens more than one time, or at most one time, because in reality, this is how the messages are delivered in the async world, right? So it is at least once delivery, or it's at most once delivery. If you think about just one delivery, how was this called? Exactly once. Yeah, that was exactly once delivery. Exactly once delivery is, however, hard to achieve. If you have any way sharing comments, I would like to discuss about that. But as you can see in this case, with the name change, even if we apply this event 10 times, it doesn't really matter. But it starts to matter when you, for example, think about some money. And if you scroll down, if we deal with the money, for example, and that we would have the event called budget increased, and let's say that would be some budget inside that event in the data, and we would just add this budget to existing budget. Well, we may get into an issue, into a trouble when we handle two events, to the same events twice, because the double budget will be visible to the user, which is not a really good thing. And obviously the budget itself in the source of truth, which would be the right model, it would be correct, but still the user might get the wrong assumption. And if they didn't report it, they may think that they have double budget, which may get us into some trouble from either a political perspective or just maybe some, I don't know, social perspective. People may be upset because they thought that they can spend twice as much money as they as they really can. So keep that in mind. That's why it's often said that when you handle events, your event handlers need to be idempotent. Okay,
Yes.
I think that's it about the idempotency. So so why you should consider and when you should consider the async read models. And there are many cases. We'll not definitely talk about all of them, but for example, if you have the write request in which you handle some information and then you publish the event, if there is 5 or more subscribers, it depends on when it's getting painful, and they all build some read models. Well, then it may be problematic, right? Because you're updating a lot of the data.
Because we covered here some kind of as an example, right? We covered very simplified situation where you actually have write model and a single read model with the same task, right? But it's not a real case scenario, right? Because you usually will have couple of read models in different, for example, even in different contexts. So then, for example, if we are talking about tasks and we know that the task on the right side, let's say, have some kind of user assigned to these tasks or just an ID of the user, in the HR part of the system, maybe we are interested also on this information. So we would like to subscribe and build our own read model based on this event, right? So then we would have at least two read models that we have to update when some event happens, right?
Yeah.
And that's actually a rare case, because what is the issue in the most of the applications? We have the write and read model, they are the same. It's the same model, which is huge, have a lot of data, and reading is costs us a lot of time, right?
Yeah.
Reading and picking up one simple value from the whole object is for the purpose of one context, for another context, and so on. We have some kind of mess, right? And now we want to decouple that, right? And we would like to have couple of read models which we can use on different contexts, for example, right?
Yeah, and the thing is that I'll just add one more thing when it comes to big models. The big models like to join each other with another big models, but then we need to filter out some data. So we only have big model for example, one user or tenant. But also we wouldn't like to have duplicates, right? Because we may multiply some information because of the inner join. And then things start to get really messy and the application is getting slow. We create big queries that are hard to optimize. This is a good moment to go for the read models, basically.
Yep. And
but
if we do it in the sync way, right, we would this time for the write will be increased, right? The updating read models will also impact writing the model itself, right? The write model.
Yes, and time and performance is only one of the reasons why you may want to go from sync to async. But another reason is that you may sometimes want to communicate with some external services, or just maybe fetch some data from other tables from the database. So it's extended. Well, okay. Once again, it's the time, but it's also if you start depending on external service to get some additional data, maybe that will be a microservice or just a service, or maybe just some SaaS application that you're relying on, it may just cause you troubles when something fails on the way. Then you have to make a decision. We talked about that in the last episode, whether you want to roll back entire transactions, so both read and write, or maybe you only want to roll back the read model and still tell the user that his save was okay. However, in that case, you need to handle the fact that your read model is it's not consistent. So it's eventually consistent. Maybe it will be if you fix that, right? Or maybe you have some mechanism to actually check the consistency. But that's those are the issues that you may have with sync read models. Obviously, it's not visible in so simple example. But if you think about your application and going into sync read models, I bet you will find some places where, well, the sync may be problematic, but there is more. There is more.
Yeah, I think from the design perspective, right? Also,
from the design perspective, yeah, definitely the boundaries. You want to talk about the boundaries?
Yeah, I mean, we already mentioned that a bit. Like, if we have like some kind of write model in one context, we don't want to, like, when we are writing it to the database or whatever, wherever. We don't want to like have any dependency to different contexts, or even if read models, if we assume that they are not, for example, piece of any context, but we still don't want to have some kind of dependencies that have like that are connected with the data that are not related to our write model in this specific context, right? But yeah, so we simply don't want to like couple those things together, right? Those data that are from different contexts in single place, right?
But at least not permanently, and perhaps that's not true in every case. Sometimes we may have just two models that go together, but like we want to know how we can get out of the situation, right? And this is one of the things. And if we want to keep the logical boundaries separated, as Tomek mentioned, obviously this is what can be done. Okay, but last and how do I say that? Last but not least. Last but not least, there is this. What I mentioned is that if you fail your updating your read model together with your write model, so synchronously, you need to make decision how you would like to roll back, right? So entire request maybe, so write model as well, or only the read model. If you go async, there is one benefit of that. If you screw up something when you try to update your read model, for example, maybe you run into a situation that we already saw here, so that the task name has changed, is processed before task has been created, right? So most of the queue drivers, they have some retry mechanism. So such a transient errors most likely will be handled on their own. And also, if you really screwed up and you need to fix your code, for example, so you need to do a deploy, there's also this possibility to manually retry, which is also awesome. And I really love this benefit, not only when it comes to building read models, but also basically when you think about the async world and, for example, communication with external services where you need to save something to them or fetch something from them. This retry thing, both automatical and manual, it's a really game changer for me.
Yep, I agree. So I think nothing else to add for this episode, right?
Obviously, this is a very broad topic. People write books about the async world. So if you have any questions, maybe some things that you would like us to cover and show some Rails examples, then let us know in the comment. We'll be happy to prepare such an episode. For now, thank you so much for watching. See you next week.
Thank you. See ya.